Welcome to Important Updates, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button so you never miss an update. Everybody is looking for security in their supply chains, until the day it all falls apart. October 17, 2025, began like any other at a high-tech factory near Eindhoven. The sun rose over the sprawling industrial park, casting long shadows across the glass and steel buildings. Workers arrived, ready for another day of precision engineering and seamless automation. The hum of progress filled the air, a familiar symphony of whirring motors and synchronized robotics. The air buzzed with the sound of advanced machinery, until suddenly, red lights flashed and the production line fell silent. The rhythmic clatter of the assembly line was replaced by an eerie stillness, broken only by the urgent beeping of warning alarms. An urgent message appeared on every screen. Critical component shortage. Production halted. The words glowed ominously, signaling a problem that no one had anticipated would arrive so abruptly. The missing parts, specialized lenses and magnetic components, small but essential. These tiny pieces, often overlooked, were the heart of the machines, enabling everything from laser calibration to robotic movement. Without them, the entire operation stopped cold. Conveyor belts froze mid-motion, robotic arms hung motionless, and the once busy floor became a landscape of inactivity. Engineers stared in disbelief. The supply chain had snapped. Months of careful planning and just-in-time logistics unraveled in an instant, leaving teams scrambling for answers. Factory manager Jan van der Meer rushed in, realizing the warnings about rare earth shortages had come true, faster than anyone expected. He remembered the memos, the industry reports, the uneasy discussions about global dependencies, but nothing had prepared him for this sudden standstill. These components relied on rare earth elements, almost entirely sourced from China. For years, the world had depended on a single supplier for these critical materials, trusting that the flow would never be interrupted. What once seemed like distant geopolitics was now a crisis on the factory floor. The abstract headlines about trade wars and export controls had become a harsh reality for workers and managers alike. The silence in Eindhoven was echoed across Europe. Assembly lines slowed, wind turbine projects stalled, and medical device production was postponed. From automotive giants to renewable energy startups, the impact rippled outward, halting progress in industries that powered the continent's economy. A single move by China to restrict exports of obscure metals had paralyzed Europe's most advanced industries. The decision, made thousands of kilometers away, sent shockwaves through boardrooms and shop floors alike. The day the machines went silent was the day Europe woke up to its hidden vulnerability. The illusion of security, built on global supply chains, had been shattered in a matter of hours. Its technological ambitions were suddenly hostage to decisions made half a world away. Engineers and executives pored over maps and data, searching for alternatives, but the options were limited and time was running out. The invisible threads of global trade had become chains, binding Europe's future to the whims of international politics and resource control. Europe's digital future was no longer secure. The promise of innovation and growth was overshadowed by uncertainty, as factories and labs sat idle, waiting for a solution that might never come. The world's tech hub had been brought to its knees by a shortage no one saw coming. In the quiet that followed, a new question echoed across the continent. How could something so small bring everything to a halt, and what would it take to start again? Rare earth elements, REEs, are the hidden lifeblood of modern technology. Despite their name, they're not rare, but are rarely found in miniable concentrations. 17 metallic elements, like neodymium and terbium, are essential for high-tech products. Think of them as technology's vitamins. A little goes a long way, but without them, nothing works. Neodymium magnets power the motors that make chip manufacturing possible. Cerium oxide polishes silicon wafers to perfection. Europium and terbium create the vibrant colors on your phone screen. These elements make our gadgets smaller, faster, and more efficient. Without them, devices would be bulkier and less powerful. They're invisible, but indispensable, embedded in everything from smartphones to electric cars. Their unique properties can't easily be replaced, making them strategically vital. And for decades, the world's supply chain has started in one place: China. How did China become the rare earth superpower? In the 1980s, while others pulled back due to environmental costs, China doubled down. Deng Xiaoping declared, "The Middle East has oil, China has rare earths." China invested heavily, accepting pollution for market dominance. State-owned firms undercut global prices, forcing competitors to close. By the 2000s, China produced over 90% of the world's supply. But it didn't stop at mining. China mastered the complex processing, controlling the entire supply chain. Western companies became dependent not just on Chinese minerals, but on Chinese-made components. This near monopoly became a powerful geopolitical tool. The world's tech industry was built on a foundation China could shake at will. Silicon Valley may be famous, but the Netherlands is the quiet giant of chip making. ASML, based in Veldhoven, builds the world's only extreme ultraviolet lithography machines, essential for advanced chips. These machines, costing over $200 million each, are technological marvels. The Dutch tech ecosystem, centered in Brainport Eindhoven, includes suppliers like NXP Semiconductors and a web of specialized firms. The Netherlands became Europe's chip engine, but with a catch. ASML and its peers relied on global supply chains for rare earth-dependent components. The Dutch miracle assumed these materials would always be available, but control over the raw materials was always out of reach. In summer 2025, China tightened its grip. Citing national security, Beijing imposed strict export controls on rare earths and high-performance magnets. The new rules created a licensing maze and slashed quotas. Prices for key elements like neodymium and dysprosium soared overnight. Western buyers scrambled, but supply dried up. This wasn't China's first move. Japan faced a similar shock in 2010. But this time, the restrictions were broader and more systematic. Europe's just-in-time supply chains became its Achilles heel. Factories had little inventory, assuming shipments would always arrive. Now the tap was off, and there was nowhere else to turn. The dragon had shown its teeth, and Europe's tech industry was in the crosshairs. The effects rippled through Europe like a slow-moving shockwave, touching every corner of the continent. What began as a distant supply issue soon became a daily reality for millions, as the pulse of industry slowed and then faltered. In Germany, renowned for its precision engineering, component makers found themselves helpless. They ran out of rare earth alloys, the essential ingredients for high-tech manufacturing, forcing production lines to grind to a halt. ASML, the Dutch giant at the heart of Europe's tech ambitions, was among the first to feel the sting. Even ASML, despite its global dominance in chip-making equipment, couldn't finish its advanced machines when just a single rare earth part was missing. The entire process stalled, with half-built machines gathering dust on the assembly line. Delivery dates slipped further and further. The once busy offices in Eindhoven grew eerily quiet, and the silence became the new normal, a stark reminder of the crisis. The crisis spread quickly. NXP, another Dutch semiconductor leader, struggled to supply the chips that power everything from cars to smartphones. Their production lines, too, stood still. Automakers, like Volkswagen and BMW, who had invested heavily in electric vehicles, were forced to slow production. Assembly lines moved at a crawl, with workers waiting for missing parts that never arrived. Electric cars require hundreds of chips and rare earth magnets, both now in critically short supply. Wind turbine projects, vital for Europe's green transition, stalled mid-construction. Even medical device production lagged, threatening healthcare supply chains. Consumer electronics companies faced mounting delays, warehouses filled with unsent orders, and assembly lines for smartphones and laptops sat idle, waiting for parts that never came. The entire tech sector, once the engine of Europe's economic growth and innovation, was suddenly paralyzed. Offices emptied, and the hum of progress faded. A tiny supply chain bottleneck, just a few missing materials, had brought vast, interconnected industries to a complete standstill, revealing how fragile the system truly was. The vulnerability was no longer theoretical. It was now an undeniable economic emergency, with financial markets reacting sharply and business leaders scrambling for solutions. Europe's deeply interconnected economy was exposed, as disruptions in one sector quickly cascaded into others, amplifying the crisis. The rare earth shortage had escalated into a full-blown crisis, forcing governments to hold emergency meetings and leaving entire industries in limbo, uncertain of what the future would bring. The rare earth crisis shattered the Netherlands' tech leadership. ASML's delays damaged its reputation and strained global chipmakers. The crisis shifted the chip war from technology to supply chain security. The US and Japan poured billions into domestic rare earth mining and processing. The Netherlands, with no rare earth resources, was left behind. Its strength in system integration couldn't compensate for raw material shortages. Investment flowed to regions with secure supply chains, eroding Dutch dominance. Europe's focus shifted from supporting the Dutch hub to building a resilient, continent-wide ecosystem. The Netherlands had won the tech battle, but was losing the resource war. The rare earth crunch hit all of Europe's tech and manufacturing giants. German automakers like Volkswagen and BMW faced electric vehicle slowdowns, missing both chips and magnets. Their green transition stalled, while rivals with secure supply chains surged ahead. Wind turbine leaders like Siemens Gamesa and Vestas saw project costs soar and timelines slip. A single offshore turbine can require over 600 kilograms of rare earth magnets. The shortage made new wind farms nearly impossible to build. Medical tech firms, like Philips, delayed MRI machine production. Consumer electronics and robotics also suffered. Europe's advanced industries were critically dependent on materials they couldn't control. The pinch threatened not just profits but Europe's strategic ambitions. The rare earth lockdown of 2025 was more than just a supply chain hiccup. It was a seismic event that sent shockwaves through every corner of Europe's technology sector. It was a wake-up call that exposed just how vulnerable Europe had become, relying on distant suppliers for the materials that power its most advanced industries. Europe's faith in globalized, efficient trade was shattered almost overnight, as ports stood still and factories waited for shipments that never arrived. The crisis proved that essential resources could be weaponized, with devastating results for economies and societies alike. The global tech race now depends as much on secure, reliable supply chains as it does on innovation and creativity. Europe faces a costly and urgent pivot, one that demands not just investment, but a complete rethinking of its industrial strategy. The continent is now investing billions to build a resilient, self-sufficient industrial base. This means opening new mines, constructing state-of-the-art refineries, and forging a coordinated EU strategy that unites member states behind a common goal of technological sovereignty. The Netherlands will remain a vital hub for innovation and manufacturing, but it can't stand alone in this new era. Europe's future depends on a robust network, from the mines in Sweden that extract critical minerals to the advanced semiconductor fabs in the south, where raw materials are transformed into the building blocks of tomorrow's technology. The lesson is clear. Technological brilliance is useless without control over the basics, and without the ability to secure the resources that make innovation possible. In a world defined by great power competition and shifting alliances, Europe must act decisively to secure its own foundation, ensuring that its future is not held hostage by external forces. The silent factories of 2025 were a stark warning, a lesson Europe cannot afford to ignore if it hopes to remain a leader in the global technological landscape.